All right, so this is the lecture for section 3.2, MAC 2233, Applied Calc. So in this section, we're going to be talking about continuous function and what makes a function continuous. And so before I get into the some of the details behind this, and probably the easiest way to kind of understand if a function is continuous, if I were to graph it here, right, on the coordinate plane, if I'm able to draw the graph of the function without lifting my pencil off the paper, then it would be continuous, right, between the values a and b, right? Because that's the way it exists if we sort of mark the values a and b there at those ends where the function continues. And so there's three conditions that have to be met in order for a function to be continuous at a point C. The first one is that f of c is defined. In other words, if I have a function, if f of x is equal to 2x plus 1, and I plug in, let's say that in this case, we're going to make x equal to c, and let's just make it equal to 2, right? So I'm going to find f of 2, so 2 times 2 plus 1 will give me 5. So it's defined for that particular value. Also, that the limit of f of x as x approaches c exists, and also that the limit of the function as x approaches c is actually equal to f of c. And so if we think about the limit of this function as x approaches 2, right, and I put 2x plus 1, well, we know that this is a polynomial function, so I'm going to get 5, right? And so we also know that f of c in this example would be equal to f of 2, which would be equal to 5. So those are the conditions that have to be met for the first part. The second part talks about continuity on a closed interval. So a function is continuous on a closed interval, a, b, if the three conditions hold. It is continuous on an open interval, a, b. In other words, for all of the values in the interval between a and b, the function is defined. I get a real number if I plug in a value in that interval. It's continuous from the right at x is equal to a. In other words, I can approach a and it'll be fine, right? I'll get a real number. And it's also continuous from the left at x is equal to b. So as I get closer to b from the left, I would also get a value, if you will. Okay, so let's look at number 7. And so for number 7, what they're asking us to do is to find out where is the function discontinuous, and then find the limit at that particular value. So we know that this is a rational expression, so it's going to be discontinuous when the denominator is equal to 0, right? So x is equal to 0, x minus 2 is equal to 0, which means x is equal to 2. So in other words, this particular function is discontinuous when x is equal to 0 and x is equal to 2, right? Because this is what makes the denominator equal to 0. And so the next thing that we're going to do is we're going to find the limit, right, of f of x as x approaches 0 from the left, right? And so what happens is, if I get really close to 0 from the left, right? So think of a number line, right? So here's 0, here's -1, right? I got -2 somewhere out here, and so let's just plug in a value, right? Let's see what's the value of this function when x is equal to -2, for example. So I have -2, -2 minus 2, right? So 5 minus 2 is going to be 3. And then this is going to be -2 minus -2 is going to be -4, right? And so it's going to be 3 over 8. So then if I, right, go from, let's do -1. If I do -1, so when I have -1 minus 2, and this is going to be 4, right? And so this is going to be 1, it's going to be -3 times that is going to be 3. And so we can continue doing this, but what you can see is that the value is actually getting larger, right? And so since it can never be zero, what's going to happen is that the answer to this is that it's actually infinity, right? Which means that the limit of this particular function does not exist. Again, as I get closer to zero from the left, what's happening, right? And so just the fact that this does not exist tells me that the limit of the function as x approaches, the limit of f of x as x approaches 0 does not exist, right? That's dne, does not exist. Now, if I were to do it from the right, and I'm just going to go ahead and do this so you guys can kind of see it here real quick, right? Approach it from the right. In other words, what happens when I plug in 1, what happens when I plug in 2, and things like that, right? And so I do 5 plus 2, and then it's going to be, well, we can't do 2. Let's do 1, sorry. Actually, let's do 3. So 5 plus 3. 3 and 3 minus 2, so that's going to be 8. And then 3, and then 3 minus 2 is going to be 1, so it's going to be 8 over 3, right? And so what happens again if I get a little closer? Let's see what happens when I use 1, right? And so that's going to be 6, and then 1 minus 2 is negative 1, and then suddenly it jumps to negative 6. And so it looks like it's just going to approach negative infinity. Again, the line x is equal to 0 is a vertical asymptote. Right, so that means that if we were to graph it, the function from 0, if this is x is equal to 0, what's happening here is that it's going up, and then over here, what's happening, it's actually getting smaller. So that limit does not exist when x, the limit of f of x as x approaches 0 does not exist. So let's see what happens, the limit of f of x as x approaches 2 from the left, right? So again, if I do the number line here, so this will be 3, right? This will be 4, and things like that. So let's see what happens when I plug in 3 into the function, right? So it's going to be 5 plus 3. Actually, over here I got 8 over 3, right? So we already know that. And so now let's see what happens when I plug in another value, right? And so, oops, sorry, my number line was totally wrong here. So this is 2, this will be 3, this will be 4, this will be 1, and this will be 0. Now it's correct. So I'm approaching it from the left, right? And so if I plug in 1, so 5 plus 1, 1 minus 2, 6, and this looks like it's going to be negative 1, which would be negative 6, right? So it approaches 2 from the left, right? And so I'm going to have to erase some of these here. So what happens when I do 1.5, right? So it's going to be 1.5 minus 2. And so, of course, here now, when I evaluate that, I'm going to have 6.5. And then for the bottom one, I'm going to have negative 1.5 minus 2. And then I multiply that times 1.5, and I get negative 0.75. Now, 6.5 divided by negative 0.75 would be about negative 4.8, right around there. And so it looks like it's going to approach negative infinity, right, as it goes from the left. And so that just tells me then that the limit of f of x as x approaches 2 does not exist, right? Because remember what we said, the right limit has to agree with the left limit, but if it's infinity, it never converges to a value, so they don't exist. Let's look at number 8. So number 8 here, again, we're going to find where is this, let me just delete this, erase this up here real quick so I can have some more space. So when 2x plus 1 is equal to 0 and 3x plus 6 is equal to 0. So 2x is equal to -1, x is equal to -1/2. Here is -6, and x is equal to -2. So it's discontinuous when x is equal to -2 and x is equal to -1/2. And so if we look at the values, if we do the same thing that we did previously, right? So what's the limit of the function as x approaches -1/2 from the left? And so when we do -1/2 from the left, and just for the sake of argument, is that it's going to be equal to -infinity. So you're going to have to plug in some values or look at the graph of the function if you want to, so to determine that the limit doesn't exist. So -1/2 of f of x, that's going to be equal to infinity. If I go from the left, it's going to be positive infinity. If I go from the right, it's going to be negative infinity. So then the limit at x is equal to -1/2 does not exist. Hold on a second. I had this written down, and I made a mistake. So that's going to be I had it right the first time. So the limit of f of x as x approaches 2 from the left, if we plug this in, it's going to be equal to infinity. And the limit of f of x as x approaches 2 from the right is going to be equal to, from the left, actually -2. So as approaches, limit of f of x as x approaches -2 from the left is going to be positive infinity, and approaches -2 from the right is going to be negative infinity. So the limits do not exist for those particular values. Doing the same thing for number 9. So here what we do is we're going to kind of clean this up a little bit. So this is going to be x minus 2, x plus 2, x minus 2, which is going to leave us with x plus 2 as the function, right? And so we know that for this particular one, x cannot equal 2, right? It's undefined when x is equal to 2. So since it's undefined when x is equal to 2, we're going to say, okay, so what's the limit of f of x as x approaches 2? Now, this is actually a polynomial function, right? Which means that if it exists, we can just plug in the value, and we get that it's 4. So then the limit, I'm going to write here. So the limit of f of x as x approaches 2 is equal to 4. And I was able to plug that in because I just ended up with a polynomial function. But remember that the particular domain, let me put that back, is all real numbers except x cannot equal to 2, right? So that would be the domain. So for number 10, we're going to go ahead and it's going to be similar to what we did previously. So it's going to be x minus 5, x plus 5, x plus 5, which is going to leave us with x minus 5. So we know that this is undefined when x is equal to -5. So in other words, x cannot be equal to -5. That's what the function is undefined. So the limit of f of x as x approaches -5 is equal to the limit of x minus 5 as x approaches -5. So it's going to be -5 minus 5, which is going to be -10. So the limit of f of x as x approaches -5 is equal to -10. Now, number 11, let me go back here real quick. So in other words, if it doesn't exist, that means that the function is discontinuous at these values, right? The values where the limit doesn't exist. So number 11, since p of x is a polynomial function, then it is continuous everywhere and discontinuous nowhere. So then we can just plug in the values and get it. So polynomial function is continuous and discontinuous, nowhere. Same thing for number 12. So number 12 is going to be the same thing as number 11 since it's a polynomial function. Now number 13, we're going to go ahead and find the values for where it's discontinuous. So we set the denominator equal to 0 and x is equal to -2, right? So then we're going to find out what's happening for this particular function when x approaches -2. So the first one that we're going to do is we're going to find the limit of p of x as x approaches -2 from the left. So remember, right? -2, -3, -1, right? 0, -4. That's my number line. So we're looking what's happening as it approaches -2 from both sides. So if I calculate this, right? Obviously I can't plug in -2, but let's see what happens when I plug in -3, right? What happens when I do, so -3 plus 2, -3 plus 2. So -3 plus 2 is going to be -1. This is going to be -1. So the absolute value of -1 is 1. So that's going to be -1. So it looks like that the limit of the function, the p of x, as x approaches -2 from the left is going to be -1. So then what happens? So this is equal to -1. So the limit of p of x as x approaches -2 from the right, right? So let's pick -1 since it's going from the right. So it's going to be -1 plus 2, -1 plus 2. So this is going to be 1 over 1, which is just going to be 1. That's equal 1. So you can see that the limit of p of x as x approaches -2 does not exist. And so it is discontinuous at x is equal to -2, right? Number 14, I am going to leave it as extra for you guys. All right, let's look at number 19. So this is a little bit different than the ones that we had done before, but we can still kind of take a look at it here real quick. So what happens is that we look at this function, and it says that when x is less than 2, the function is equal to 1, right? So it means that, let's say, f of 1 is equal to 1. Now it says that when x is between 2 and 4, we're going to use this, which is equal to 5, right? And so if I was going to find the limit of this particular function, what I'm going to have to do is I'm going to say, okay, what's happening at 2, right? What's happening at 2, if you will. So here, let me do the other one here. So f of 4 is equal to 4 plus 3, right? Which is going to be 7. Now, if x is greater than 4, is also equal to 7. So then the limit, right? This limit as x approaches, so the limit, right, of f of x as x approaches 4 is going to be 7. So that actually exists. But we see that there's something going on here with 2, right? So let's see. What happens if I plug in 2, right? So the limit of f of x as x approaches 2 from the left is equal to 1, right? Because it's telling us that if x is less than 2, it's going to be 1. And then the limit of f of x as x approaches 2 from the right, it's actually going to be, if I plug in 2, is going to be 5. So therefore, f of x is discontinuous at x is equal to 2, right? And the reason being is for this reason right here, right? That's why it's discontinuous. All right, let's look at number 20, right? And so we're going to do the same thing, right? And so what is the limit of f of x as x approaches 1 from the left, because it's saying that it's going to be equal to If x is less than 1, it's going to be x minus 1. So what happens if I calculate or if I evaluate this limit, right? So as x approaches 1 from the left, well, what's a value for 1 from the left? Would be 0, right? 0 minus 1 is going to be negative 1. Right, so it looks like if I approach it from the left, if x is equal to, if I go from the left approaching 1, I'm going to get negative 1. But what happens if I plug in 1, right? What happens if I do that? So the limit of f of x as x approaches 1 from the left, right? It's going to be 1 minus 1, which is going to be 0. Right, let me make sure I wrote this number 20 correctly. And that's actually a 1, not a negative 1. Let me make sure I get that right there. There you go. And so what happens from the right, right? From the right, the limit of f of x as x approaches 1 from the right is going to be equal to 1 squared plus 2, which is 1 plus 2, which is 3, right? I don't know if I wrote this one right. Is this 20 or 21? Hold on a second, because I think I made a mistake here real quick. So this is actually 21. And yeah, this is actually 21. Everything else is okay. It's just not number 20. Right, let me double check it for 21. I don't even know where I get these values from, to be honest with you. All right, let me go back here real quick. Let me restart. Let me rewrite this particular problem, because I think I didn't write it correctly. So I think I was supposed to do number 20. So f of x is equal, I apologize for that mistake, x minus 1, x is less than 2, 0, 1 less than x, less than or equal to 4, and then x minus 2 when x is greater than 4. All right, let's do this one this time. So I do apologize for those last few minutes. So let's see what happens here, right? So number 20, it says, if x is less than 2, right? So if I plug in, so the limit of f of x as x approaches 2 from the left, right? It looks like it's going to be, let's say 2 minus 1, which is going to be 1 there, right? Now, it also says that for this particular one, let me see, x is minus 2. That should have been a 2 and not a 1. That should be a 2. That should be a 2. Okay, so then what happens, the limit of f of x as x approaches 2 from the right, and it looks like that's going to be 0, right? Because it says if x is greater than or equal to 2, it's going to be 0. If x is less than 2. So you can see here that is going to be discontinuous when x is equal to 2. So the next one would be what happens with 4, right? So what's the limit of f of x as x approaches 4 from the left? It looks like it's going to be 0, isn't it? And then the limit of f of x as x approaches 4 from the right, it's going to be 4 minus 2, which is going to be 2. So therefore, this function is discontinuous when x is equal to 2 and when x is equal to 4 for number 20. All right, sorry about that confusion. Let's go down to number 36. Number 36 is a word problem that we're going to go ahead and do. And so let me just open up my textbook here real quick and get to section 3.2 and look at number 36. So for number 36, what they're asking us is the following. They're asking us, it says, the cost of transporting mobile home depends on the distance, x in miles, that the home is moved. Let C of X represent the cost to move a mobile home X miles. One firm charges the following. So what it does is it's charging $4 per mile, right? So let me go ahead and do this here. So it's going to charge basically 4x, right? 0x, $4 a mile if it's between 0 and 150 miles. It's going to charge $3 a mile if it's between 150 and 400 miles. And it's going to charge $2 per mile if it's going to be greater than 400 miles the distance. And so we're going to find out, okay, so for A, what is the cost for moving at 130 miles? So 130 miles, we're going to use 4 times 130, and that's going to give us a total of $520, right? For letter B, it's saying 150 miles, right? So then that's going to be, since it's 150 miles, it's going to be 4 times 150, which is going to be $600. For part B, it's going to be 210 miles. 210 miles is going to be $3 per mile, so it's going to be 3 times 210, which is going to be 630. For part D, it's going to be 400 miles. And so that's going to be 3 times 400, which is $1,200. And then part E is 500 miles. And that's going to be 2 times 500. Since X is great. Oh, it's 2.5, sorry. Let me rewrite this, 2.5x. And this is going to be 2.5 times 500, which is going to give us $1,250. So it looks like this particular function is going to be, where is it discontinuous, right? So let's try 150. So we're going to go, what is the limit of the function as x approaches 150 from the left? So it's going to be 4 times 150, right? And then so when you calculate that, you're going to see that what you get is not going to be the same as the other one. So that's going to be 600, right? And so what is the limit of C of x as x approaches 150 from the right? And so that's going to be 3 times 150, right? And that's going to give you 450. So you can tell that it's discontinuous when x is equal to 150. Now the next one is at 400, right? So what's the limit of C of x as x approaches 400 from the left? So that's going to be 3 times 400, which is equal to 1200, right? And then the next one is going to be the limit of the function as x approaches 400 from the right. It's going to be 2.5 times 400, which is going to give you $1,000. So you can clearly see that it is also discontinuous at x is equal to 400. And that wraps up section 3.2. Thank you.